Hey Algebra 2 gang, so this is kind of your lesson outline for today here at the top of this page. Basically today is a big giant work day, but I need you to get the most out of it that you can. Please do not waste this 50 minutes and do nothing, because I know that some of you most definitely need this time. So use this day with a sub as your advantage to get as much done as you possibly can. You may use the people around you, as long as you're still understanding what is going on. If you let somebody else do your work for you, whether that's another person or the internet, it's not going to help you come Friday's test. The 4 things that I would like for you to work on in this order would be, number 1, finish any assignments that you have missing. 6.1 through 6.8. They are all due Friday because that is the day of our test, and you need to have practiced this stuff if you plan on actually being able to do it on the test. Most of the stuff is new enough that if you've never done it on the assignment, you're not going to be able to just randomly guess at it on the test. 2, there is a really short Delta Math Unit 6 check-in. It is 10 questions long. It should take you like 5 minutes or less. There is one problem you might want to have scratch paper for. It is an exponential growth problem in which you have to calculate time. The other exponential growth you're just typing into a calculator. You could do that without writing it down. There's some evaluating logs and condensing logs. That's it. 10 questions, not too long. Don't forget about that one if you choose not to do that in class today. Number 3, if you have not taken or finished your Unit 6 Quiz 2, you need to get it from the sub and work on it. Hopefully finish it so that I can come get it after school, grade it for you, hand it back to you tomorrow. If you do not plan on taking that right now because you've missed so much and you're still getting caught up, you need to send me an email and talk to me about that. Okay? If you're that far behind, we need to have a discussion because the test is 2 days away. And then the 4th thing is, if you're all the way caught up and you've taken your quiz and it's done, you can start working on the Unit 6 review. They're clipped to my front board. If you are having some trouble on 6.7 or 6.8, I'm going to do these 7 problems from those 2 assignments. Feel free to grab your assignment and write them down with this to see if that helps. They are questions that have specifically been asked a lot, or I know that there's something that could make them really tricky. So I'm going to go through these 7 problems. If you need help on them, stay on this video and watch. Otherwise, go work on what you need to work on. All right, so on 6.7, question 16, it's on the front side. You want to subtract this 7 that's in the front first. That's the weird part about this one. The answer to it is also just a little uncomfortable, FYI. So 50 minus 7, 43. Then if x is in an exponent, you need to invert that exponent. The inverse of an exponent is a log. So I need to do log base 6 because 6 is the base of that exponential. And that crosses that out. Then I need to go do log base 6 of 43 in a calculator. I've actually already done it. Actually I got rid of it. Six 43. 2.0991. Now, I'm not going to write that down, but if you wanted to know what it was, that's what we're going to do. I'm going to finish solving that in the calculator in just a second. The reason why I'm not going to do that right now is because if I've got 3x plus 2 equals this, I want to subtract 2 from both sides to start getting x by itself. That gives me 3x equals log base 6 of 43 with a minus 2 afterwards. Then I would divide by 3, like that. This is the exact form of your answer. Basically, it's what you would be typing in your calculator to answer it. Then I'm going to go to my calculator, and I'm going to subtract 2, and then divide by 3. Notice how I did not round at any point. I'm waiting till the very end. Now that is 33 thousandths, which would be 300ths, 0.03. I always want you guys to round to the nearest hundredth. 2 decimal places, and you're good to go. Okay, number 17 is a word problem. That was the last one on the front side. This is the first one on the back side. The difference with this word problem is you know the beginning and ending amount, and you need to find the rate, or sorry, the time. So I'm going to zoom in on this one a little bit. Basically, you should know that if he's starting at $12,000 and he's got a 3% interest rate, that's going to be 12,000 times 1.03 to the power of x, or t for time, whatever you want. I don't know that exponent though, so you have to put a variable there. What I do know is that I'm trying to find out when it equals 20,000. So that's what it equals on the other side. Now I have to solve this and get x by itself. The first thing that you should always do is this is multiplication. So I'm going to divide by 12,000, which 20,000 divided by 12,000 is 1.6 repeating. I'm just going to call that 1.67. And on the other side, all I have left is the 1.03 to the power of x. I don't need those parentheses anymore because there's nothing else over there to make the parentheses important. And I'm going to go ahead and move that over just a little bit. Now, I'm in the same place I was on the last problem where I need to be able to get x out of the exponent, which means I need to use a log. And the base of that log is the 1.03 because that cancels. So then I need to do log base 1.03 of that decimal that I just got in my calculator. So here's how I'm going to do that. I'm going to do math menu, go down to the log. I'm going to type 1.03. Then I'm not going to type that decimal right here. I'm going to hit the up arrow till it's highlighted and then hit enter. So it copies the whole thing down for me. You really, really, really can't round in the middle of a problem. So I need to copy that down. And then that gives me 17.28 years. And the way that I know that it was years, not months or weeks, is it says per year. So that was your unit for time. That's it. Okay, the last one I'm going to do from 6.7 is number 24. This is one of those quadratic formula problems, just a heads up. The reason why I picked this one and the reason why it's hard is because you got to get rid of that log, and most people forget that a regular log, or the common log that's just log without a number, is base 10. So to get rid of the log, I need to exponentiate both sides with a base of 10. So I'm basically making both sides an exponent on the number 10. Now that cancels this log out, so I have x squared plus 8x equals 10 to the first power, which is 10. Then I want to subtract that 10 to the other side, because when you have an x squared, you want everything on one side so you can factor it, which is where I would be looking for two numbers that add to 8 and multiply to negative 10. That's just not possible though. So when that's not possible, you have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. B is 8, a is 1, c is negative 10. So negative b will be negative 8 plus or minus the square roots. B squared, 8 squared, minus 4, a is 1, c is negative 10, all over 2, a is 1. Now what you're going to do is this part right here first. 8 squared minus 4 times 1 times negative 10. 8 squared minus 4 times 1 times negative 10. That's 104. Then I'm going to do negative 8 plus the square root of 104 divided by 2, and negative 8 minus the square root of 104 divided by 2. And those are going to be my two answers. I want you to go ahead and take it all the way to decimal form. So -8 plus the square root of 104 divided by 2. -8 minus the square root of 104 divided by 2. So my answers are 1.10 and -9.10. Now, before I circle those as my answers, I need to look back over here. What was inside my log was x squared plus 8x. So I need to do 1.1 squared plus 8 times 1.1 and -9.1 squared plus 8 times 1.1. Both of those, oh, sorry, I did that last one wrong. -9.1, I switched numbers. Both of those answers are positive. They're actually both the exact same, 10.01, if you ignore my mistake in the middle. None of those are negative, so both of those answers are solid. The only time you cross it out is if that answer, when you plug it into this log part, is negative. Only the inside to the log. All right, let's talk 6.8 for a second. On 6.8, this was natural log and compound interest and continuous interest. I feel like the problems with this one are the same as the problems with 6.6. So if you're having trouble with that one, this might help too. The only difference is those were log, these are natural log, ln, not in. When you have two logs being added, you need to multiply those two things together. So 4 times 2x plus 5. Now I'm writing that at the top because I'm not actually going to write that down here. I'm going to go ahead and do 4 times 2x and 4 times 5.
Okay, so the calendar invite says 12. Get there at
12:45.
ain't gonna happen.
Well, so you're supposed to get your subs to come here at 12
Yes.
because then you get to go have lunch and be there at 12:45. So she was trying to make sure that everybody gets lunch.
I just have second lunch. Just like
I think we talked about it in co-op, but I don't think you were there. Why weren't you there?
making video.
No, it wasn't today because we all made videos today. I don't know when it was. But yeah, so that's why your subs gets here at noon, so you still can go get lunch.
Gotcha.
Okay, now if I have a log on both sides, those logs, like this has to equal this because the other part's the same, so the inside has to be the same. Or the natural log is the inverse of e, so you would do e to the power of both sides and they would both cross out that way too. Either way, I have 8x plus 20 equals 4. Now I subtract the 20, 8x equals -16, divide by 8, x equals -2. Done. Now I picked number 16 because this one's going to be a decimal answer. It's actually not that hard, but you've got to get this natural log by itself before you can try and get rid of it. So you can't cancel out a log or an exponential unless it's the only thing left on that side. So I've got to subtract the 5 first. That's going to give me 3 natural log of x equals 9. Then I would divide by 3. So now I have natural log of x equals 3. To get rid of a log, you exponentiate both sides. The base of a natural log is e, so you're going to do both sides to the power of e. And x equals e to the 3rd power. That is the exact form of that answer, or approximately 20.09. I would list both of those in your answer so that I know what you typed into your calculator as your work. especially because then I can give you points if you knew what you were doing, but somehow you got the wrong thing in your calculator. There, that's better. The same kind of thing is going to happen on number 11. The e is already by itself, so I'm going to go straight to the natural log to cancel it out, which leaves me with 4x minus 3 equals natural log of 5. Now, if I want to get x by itself, I'm going to add 3, boom, and then divide by 4, right? So x equals the natural log of 5 plus 3 divided by 4. And then I'm going to go ahead and type that into a calculator to get the decimal approximation. But that right there, what I have right now, is my exact answer before I've rounded. So natural log of 5 plus 3 divided by 4. 1.15. Done. Now the last one is just another word problem, kind of like number 17 from 6.7. It wants to know how long it will take to double an investment of $4,000 if interest is compounded continuously at 4.5%. The second you see continuously, you're using PERT. A equals P to the power of RT. So A is going to be 8,000 because I'm doubling 4,000. Double 4,000 is 8,000. P is 4,000. R is 0.0, sorry, I forgot the E, 0.045. And we don't know what T is, that's why it's asking how long. Now, just like number 17, basically you've got to ask yourself, how do I get T by itself? Well, start by dividing by the 4,000, just like we divided by the 12,000 on number 17. That's 2, because we doubled, so it should equal 2. E 0.045 T. Now we've done a couple of problems like this. How do I get rid of an E? Natural log, ln. So now I've got 0.045 T equals natural log of 2. I'm going to move this whole thing over because I didn't realize I was out of room. Now, how do I get rid of the 0.045 in front of T? Divide, because that's multiplication. One of the hardest parts of math is realizing that if there's no plus or minus sign, everything is multiplication. And then I've got to go divide natural log of 2 by 0.045. Make sure you close your parentheses when you do that. 15.4 years. Now, fun fact, if there was another problem that said also 4.5%, also continuously, also doubled, this 4,000 doesn't matter because doubling $4,000 is going to take the same amount of time as doubling 1,000 or 10,000 or 1,000,000. Everything doubles in the same amount of time. It's just how worth it is the investment to double, because doubling $100 is far less important than doubling $1,000,000.